Hello! In this episode of window brick machining, we are not going to weld. Well, I'm apparently trying to avoid that as much as possible. Well, no. There was a request from my friend to make a part for his, let me see. Well, sahausohjain. Well, that's a sewing jig. Well, I assume this is from a bandsaw or motor saw or chainsaw or some saw. Thing that guides your cutting. Well, anyway, I believe it's just an attachment for a device like that. Well, it's a lump of metal with holes in it. Yeah, so let's do it. So, well, here is the lump of material, and well, it's just mild steel, something like I don't know what the size exactly is at the moment, but it will be 50 times 50 times 70 millimeters when I'm finished here, and I try to make it a cubic one. This is a standard procedure. So actually I have here a copper thing in between the moving jaw and the workpiece to make it be aligned with the backside of this thing, which is that isn't straight either. But when I have done this side, I can then turn it like 90 degrees, and then we have a more capable holding surface and we can start taking decent cuts. Now I'm really trying to avoid really heavy cuts because this workpiece can move in the vise because it can. Well, so let's start with this one. Well, let's hope there comes no more blackouts. Yeah. So. The surface is here. Well, that's a surface. Let's see now. We should be now at quite exactly at 50 millimeters this way too. Okay. Yeah, exactly. Good. Oh, a lot of what a mess. Well, this cutter really throws chips everywhere, and a lot of them. So now, I will first clean up the mess here. It's a little bit too much for my taste. And after that I will do the ends. This is about 80 millimeters long, it should be 70. So that's the next. Well, okay. I now depured this workpiece. It's really well. There was a horrific pour. Well, and I cleaned up everything. This roughing end mill is really nice. It produces chips which are easy to clean because they don't spread all over the place. They are very local. Okay. Now, the next step is to drill a 25 millimeter hole about here. And, well, the tolerance of that hole is minus nothing plus half a millimeter. Ha! That's very generous tolerance, I would say. But let's see now. I have to attach this to the vise first. And in this case, however good this vise is, it's not perfect. When I use the hydraulic assistant, when it squeezes it, it will lift this jaw a little bit. So therefore I'm knocking it, and as you can see, these things are pretty lively in there. This didn't work at all. Okay, now that works. Okay. It seems to bounce back. Huh. It's not very easy to get it. Huh. Why? Well, okay, let's try it this way then. If it works better. Yeah, this is really... Okay, now. Yeah. These are... Okay. Okay, now that is okay. It's not easy to get this correct. That's bad. Do we have burrs there or something that prevents it from getting correctly into there? That's now tight. That's still tight enough. Okay. Uh-huh. Let it be there. It's, well, it's straight enough. So now it's there. Hopefully. Let's put these things away. And now I need to dial this in. First this face. The hole should be here, like 25 millimeter from this edge and 25 millimeters from this edge. So first we do this direction. And yeah, okay. This x-axis is really sensitive, so I need to lock the table a little bit so that the weight of the handle doesn't oh, too much. There. And now I zero my dial here. There is a scale here under. I don't zero it, I put it to 10 here. Like that. And then I also zero this dial, this dialing the wheel. So now we know the exact place for that one. That's there. And then we need to take the same action with the Y. I think there we are. Lock it, and then I have to, we have also a scale in here under. So, and this one I can set on 0. There you are. And then 0 this hand wheel dial here. Okay, there you are. Now we are done with this. So we know our exact location. So and now let's take this thing away. We don't need it anymore. You have to be really careful with this one. If it drops on this tip, it will break. So yeah. Okay, now next step, I will find a suitable drill for that one. Let's see what we have here. It's a pilot drill, and I don't want to. Maybe 12 millimeters is good enough. Yeah. Okay, this is big enough so it pulls the chips out from the hole easier than a very small drill. Of course it doesn't fit there now. It's a very long thread actually, yeah. And this is a suitable drill because now we have flutes long enough. Yeah. So it was 12. So 12 millimeter collet. There you are. And now I of course check the shank that it's okay. And it seems to be 12. Yeah, okay. There it is, our drill. And now let's pull this down a little bit. And now first we put this into our 0. Now it's over the edge. And now 15. 25 I mean. 10, 20 and there's your 5. There. I need to lock the X here. You don't, we don't need to move this anymore while drilling this hole, so X is now there. I will check it with the ruler if this is really the case. 25 millimeters. Check my drawing first. Yeah, 25. Just eyeballing. Yeah, it's 25. And then this one too, to 25. There is 24. That's 25. Let's see. Yeah. Okay. It's about there. And then the speed is Well, it's okay. I don't want to run this any faster than this. Well, maybe a little bit. Now it's 170 revolutions per minute. I think that's good enough. And then we start drilling the hole. Oh man! So now I just collect these chips. Well, they are really hefty. But yeah, that's the way you drill a hole in a milling machine when you have the power feed. And if your revolutions are suitable, these are actually quite thick. And well, I had to break the chips by stopping the feed from time to time so that I don't get whip slashed with these damn things. They are dangerous actually. Okay, now that's one hole done. Okay, now it's going to be two holes here, one here and one about there. And they are in the midway, so our vise, I mean the table is already adjusted in the Y direction, so I don't need to do that anymore. Because this is, it was against the back jaw. So now just the X. So let's see. And again, see, when I leave, the handle will move the indicator. I lock the table a little bit so it doesn't move on me. Easier to do this. That's our place. Oh, no, that's not our place because, well, the workpiece isn't tightened there. It's loose. Wow. Of course I need to tighten this. Oh, that's funny. Okay. A little bit from the back side. Okay. This is, oh yeah, okay, let's do it that way. There you are. And then we dial this in. Now it's tight. Oh man, and I loosened the table lock, so man. Okay, now it's easier to do this. There you are. Lock the table there. So that's the 0 point. It's about 5 millimeters in different place as it was when I drilled the big hole for some reason. Okay. Yeah. And now I can loosen this. Okay. Then we change something else here. Well, there is a thing about these holes. Their depth is quite exact. They should be, yeah, 15 millimeters deep. But it's measured from the flute edge. Man, that's actually quite inaccurate way of doing this. And now again I need to be really careful when I loosen this, because this thing will drop if I don't hold it all the time. Cut it out in one piece. Yeah. So now, well, let's see. These will be M8 holes, and now I have a 8.6 millimeter drill, but that doesn't have a split point, and it seems to be a little bit dull. So I will make these 8.5 millimeters. And then I have a very good drill which I can use to drill the holes, but I need to monitor the depth somehow. Well, let's see if I can figure out a better configuration for this. This is not good for you. So, yeah, okay. I configure this filming environment, and after that I will drill the two holes. Well, that's the wrong drill. It should be 6.5 millimeters, not 8.5. Holes are now there, and well, okay. Now this needs to be tilted in 45 degrees, and how do I do this? So this has to be level. It has to be level. Well, so it has to be level. Oh, yeah. I have a machinist level which I can use for this. Just knock it a little bit. A little bit more. Oh man. Hmm? Easier said than done. Oh yeah, okay now. I think we are there. There you are. Yes. Now it's about level. Yeah. I will be power cleaning this now. There you are. That's one hole. And now I collect the chips again. They flow all over the place. So now, well, I have to think about how to do the next steps because these need to be threaded, all the 3 holes. Well, I think I do the threading as the last thing. Now, next step will be to remove some metal from this lot actually. Okay, well, here is now the setup for the last milling operation here. This workpiece, there has to be removed a quadratic piece out from there. There is 1 millimeter space between the jaw and the cut line, yeah, and quite a lot of material removal, I would say. But for this end mill, that's not a problem. What is a problem here is work holding. I'm a little bit suspicious about. I'm always expecting the workpieces to pop off from the vise. No matter how hard your vise is, it still works with friction. But you can clamp the things mechanically so that there is no way it can jump off from the vise. And this is exactly what is done here. One would say that I'm wearing both belt and holders. Yes, I do. I'm almost paranoid with this. Yeah, okay. So we have the parallels here under and they are really tight at the moment. You cannot move them. It's clamping this way very hard, and also we have this 16 millimeter rod which is threaded through the hole. There is this copper tube protecting the workpiece from getting marked with this because it's clamped down with this. So now it cannot, it physically cannot pop off from this. I suspect that you can start moving the entire milling machine by trying to move this piece. So now I can take whatever cuts I like well, of course, the horsepower of this milling machine is limiting me. But now it doesn't come off and it stays in place. So, well, what else is there? Well, nothing much. Just go on. Okay, now as you can see, we have poken through there. What this means that the support on the top of the piece has vanished. So it tries to bow now from the thinnest part there, but well, it can't because we have here the parallel under, and then we have those which push it down, so it cannot bow, and that's a really good thing. So yeah, without this system with these, I suspect we would have well. I just suspect, I'm again paranoid, but I suspect that we would have a catastrophic failure by, well, the workpiece popping off from the vise. But now, since it cannot, and it cannot bow, nothing changes. I had a very hefty burr here, for some reason, I don't know why, but I just tested if the height has changed, and it didn't. It just did a burr there. I don't know why it did that kind of thing, but yeah, okay. So now, well, we are going to mill the next round, and then we have yet 6 millimeters to go after this. Then we should be on the correct level. And I'm using this to collect the chips. Well, I could probably get half of them, but that's half of them anyway. So yeah, okay. But now let's go on. So that was the roughing, and now we have here just to make the finishing touches here. So I measured this thickness, it should be 17, it's at the moment 17.6 millimeters, good. So 0.6 millimeters away from that surface. That one should be 25 millimeters from the backside, and at the moment it's 31. So 6 millimeters, which is quite a lot for this end mill. Well, maybe 3 2 millimeter passes. Let's see. But the intention is to get a better surface finish and get it accurately into that one. I will deal with that surface first. Shouldn't be too hard. So let's see now. I think about there. I will actually place it here. It's easier this way. I can see where we are. Well, that's good. I think a little bit higher. Yeah. Okay. It will be scratching the copper thing. And I'm running this a little bit faster now. It's 170 revolutions per minute. And now I will touch it. Very, very gently. There you are. Yep. Lock this. Oh, this was in zero. Very good. So we will take 2mm passes. So 2mm first. There is your 2. And then we shall see how it looks. Well, what else? What am I missing here? Probably nothing. Okay. Oh, wow. Well, we did some milling for copper here as well. So now this workpiece, the milling operations are now done. Next step will be, of course, a lot of deburring, and then I go to the milling drill press and do the threading, and then, well, then this workpiece should be done. Well, now I just dismantle this setup, clean up the mess, which is actually not a lot this time, and then I will, yeah, see you in the drill press. So, I deburred this workpiece, and I aligned it with the 8.5mm drill, so that now the hole is, well, it's in line with the drill press. So when I make this thread here, let's have a little bit of a tension there, like that, so it comes, well, in the correct direction. And this is very simple thing to do, just turn the thread. I use these for chamfering because they are really, when you are doing chamfering freehand, they produce a very nice result. And there you are, that was first, that was second, and then the M10. And then we are, oh, wow, I did tighten this. Yeah. So we have one there, and you will soon see how nicely this does. Yeah, a little bit more. Yeah, now it's done. Yeah. Let's see if it still works. Yes, it does. Now we still have one thing to do here, and it's the backside here. I will do that with a Dremel, and then we are done with this workpiece. Okay, this workpiece is now ready. It's here. Well, decent. It looks decent. It isn't fine. The surface finish, you can see the tool marks everywhere, but I think this will serve the purpose it's built for, holding, well, sahausohjain. It means guide for, it's probably a bandsaw. I'm pretty sure of that. It could be another type of saw as well, like a circular saw, I don't know. Anyway, now, well, so, of course you were disappointed because we didn't have the welding in this episode. Well, now I make a promise. In the next episode you will be see me trying to weld, learning to weld, welding. That will be fun. Actually, it will be fun. Till then, bye!